Consider the data below that which shows the number of Android apps in hundreds. So what we're going to do is we're going to enter this data into the calculator. So what you want to do is you want to go to Stat and then Edit. Stat and then Edit. L1 is your X list. In this case, it's the number of months since December 2009. So 1 represents, so if you're 1 month past December 2009, January 2010. Very good. So the lighter blue, we're going to go from 1 to 12. So 1, hit enter, 2, 3, so on and so forth. Since this is pure calculator, make sure that what you've typed in is correct. I can't see if you did anything wrong. And then your Y values, so 4640, go into L2. 5694, 9421, so on and so forth. So again, after they are all typed in, go through each and every one to make sure they're perfect. Notice that there was a nice steady incline for the first 7 months, and then it dipped by 1,000 over the next 2 months. So this is not going to be the greatest equation that we get here. It's going to be pretty close, though. So the whole point of regression is to find an equation that matches your data. The better the data means the better the equation, and then you can use this data you can use this equation to predict future data. That's all we're doing. So anytime you hear populations of certain countries is this many in 2025, they figured out the equation that matches the population for that country and plugged in 2025. That's all I did. We're going to do the same thing. It's just number of Android apps. Okay? And it's an exponential equation. So once your data is in there, to get your exponential regression equation, you want to go to second and then quit. I'm going to clear my screen because that's other stuff. So go to second, quit. Go back to stat. Scroll over once to calc. And you're going to look for EXP-reg. EXP-reg. And basically hit enter twice. Depending on the data, it may take a little while for it to compute. This one was quite nice. All right. So, what was our A value? Give me 2 decimal places. 53. And what was the B value?
1.16.
Okay. And I think the equation at the top says A times B to the X. Is that correct? All right. So our equation that we're going to use for B and C would be Y equals 5377.94 times. So awesome board work right now. Totally just did that. What can you do? All right. So for part B, how do we approximate the number of apps in April 2011? So X was the number of years since the number of months since December 2009, excuse me. So April 2011 is how many months since December 2009? 16. Yeah. So what do we put in for x? 16. So if you would, put in 16 in for x. $57,802. Okay. Notice this is really in hundreds. So what is that really? That is really 5,780,212 apps. Because we moved the decimal point 2 places. Is that okay? That's a lot of apps. Huh. Okay. And then part C, when will there be 3 million apps in 1 month? Well, we know in April that there's already going to hit 5 million, but by December 2010, we were still at 2.7 million. So it's got to be somewhere between January and April. So don't write that as your answer. I would like to know which month specifically. So we're going to do this on the calculator because we don't know how to solve this equation by hand. 30 million is how many hundreds? 30,000. Okay, so keep that number 30,000 in mind. To do this by the calculator, we need to plot both equations. So you're going to go into your y equals. In y1, you're going to type in the 5377.94 times 1.16 raised to the x power. In y2, we're going to type in 30,000 because that represents 3 million. Before we hit graph here, let's make sure our window is sufficient. Remember, x is the number of months since December 2009. And since we just talked about it, it's got to be between January and April of 2011. So that would be between 13 and 16. So why don't we just say, for some breathing room, we'll say x min is 12 and x max is 17. Keep the scale as 1 for the x's because we're only going from 12 to 17, so those are relatively close. But for the y's, what should we make the y min and max? Yeah, remember we have to surround 30,000. So let's go from 25,000 to 35,000. And what would it be? Oh, Mike, yes. You put those in the wrong place. I know. All right, as long as you know. Good job. Why don't we make the scale 5,000? Doesn't really matter there. And just hit graph. This is why you should research your problems before you actually do them in class. That's okay. So notice my window's wrong because it actually hit earlier. Oh, I'm a sad panda. All right, let's go back to this window. Let's change the x min. Let's say 10. I'll explain what's going on, why we have to go back. And let's hit graph. Bam! I changed the x min to 10. Okay. To find the point of intersection, we do 3 things. We go to second, calc, and notice number 5 there is intersect. Second, calc, and then intersect. The calculator asks for 3 things. First curve, second curve, and guess. You may have a cursor on your screen. I totally don't even have a cursor on my screen because it's way off there. So if you want, you can move the cursor left or right until you see it. But basically, since we only have two curves, on first curve, just hit enter. On second curve, just hit enter. And when it says guess, move your cursor close to where it intersects and hit enter. So according to the calculator, it actually happened within 2010, because that looks like halfway through November there, because it's 11.58. Okay. But according to our actual data, we were only at 2.4 million apps in November. The reason being is our regression equation isn't the best. And it's because of it's trying to fit in these values right here, which do not fit the pattern anymore. It should have went from 18,000, 19,000, 20,000. It should have increased, but it dipped there. So because it dipped, the equation's off. And because the equation's off, our approximations are off. Wah, wah.